Good morning, everybody. Thank you for having me today at the H2 Tech Insight stage. My name's Jake. I am the Business Development Manager for Petrofacas Energy Transition Projects. And today I'm going to talk to you a little bit about things that we've learned in the hydrogen industry, in our pre-feed and feed experience in the past, but also as we start to transition to EPC. So as you might know, Petrofacas, renowned historically for traditional oil and gas, okay? It's no secret. I think we've given that away with the logo, the little drop on the logo. But it's very clear that we recognize there's a requirement to move away from oil and gas and to move into the energy transition world. Energy transition is not new for Petrofacas. That's one thing I want to make really clear. So when I say it's not new for Petrofacas, we've been delivering projects in wind for many, many years. And these offshore wind assets you will have likely have had power from in the past, and will continue to do so as we move forward. So a little bit about Petrofacas and the energy transition team that we look after. So we do everything from design, building, operating, and finally implementing the systems, okay? So whilst we think that's really critical, making sure we've got that knowledge in complex projects, we also make sure that we understand the need for pre-feed and feed. So why oil and gas, and then why move into hydrogen, and why all these wonderful opportunities? So as you'll see, the traditional oil and gas platforms are very, very complex. If you'd have gone back 50, 100 years, you'll have seen these systems were very, very complex to implement. So we can apply that knowledge into our new energy transition era. So how does that look for us as a business? So we look after the HVAC. So when there is wind turbines at sea, that wind turbine needs to convert from AC to DC, DC to AC, to make sure we're moving that molecule of energy, i.e. electric, right to the grid in the most efficient manner. We also do waste to value, and there's also a very critical part of our business, which is the blue and green hydrogen, which is what I'm going to talk to you a little bit about today. So really, new energies requires a different approach to oil and gas. Oil and gas is a known market right now. So how do we sort of transition away from doing that? One of the biggest things you want to take away from today is that Petrofacas is technology neutral. So what does that mean? We won't give you a dedicated technology to utilize. You will always be given the right technology for the right price, for the right system. So building partnerships is important, but you won't be seconded into a system that has an electrolyzer, for example, that's specified because we're purely in a partnership with them. So energy transition projects, what does that mean for you, and what does that mean for us at Petrofacas? So we're built up now of 5 different regions, okay? So we're focusing heavily on carbon capture, utilization and storage, hydrogen, waste to energy, offshore wind, and emissions reduction. And the area that we're focusing very heavily on at the moment is in hydrogen. So what does this mean for Petrofacas, and how can we sort of implement our experience in hydrogen and grid and wind, solar, gas? Well, really we're focusing heavily on blue and green hydrogen. If you'd spoken to me a year ago or maybe 2 years ago, I would have pushed very hard on the renewable green side. We're starting to see how green hydrogen at the moment actually is very, very expensive. There's no secret about that. We need it to get to green, but actually if we're moving away from green, we actually need the support to get to green by using blue hydrogen. Why do we need to use blue hydrogen? We've got the infrastructure, we've got the grid, we've got the gas, okay? So let's see this as a bridge, and I'll go into that in a little bit more detail shortly. It's very clear, though, that hydrogen is not going to be the only solution, and that's one of the biggest things I want you to take away from today. So we believe hydrogen will play a part of the transition. We don't believe that it will be the total transition, but it will work synergistically with carbon capture and storage, with waste to fuel. And we've seen that in SAF recently. SAF is a really exciting market for us, and we're working very closely with lots of aviation experts to see how we can get SAF into these aircraft going forward. But also, how do we decarbonize the manufacture of energy, which is traditionally done by fossil fuels, okay? So sites that are using coal, how do we decarbonize them? How can we carbon capture? And how can we utilize an off-taker of hydrogen to create energy going forward? So just very quickly, everybody has seen this a million times. I just want to go over the major sort of hydrogen groups. You've got green hydrogen, which essentially uses a renewable source to create the energy, stores it, converts it, and then you can flip it between hydrogen and between energy. And then you've also got blue hydrogen, which is essentially cracking the molecule via a reformer, but also linking that nicely with carbon capture, utilization, and storage. There's also lots of other different types of hydrogen. We'll have a whole rainbow soon, I'm sure, but the most important ones for us are grey and yellow, yellow being linked with electrolysis. So hydrogen, what's the benefits for the new people in the room about what is this molecule? So the density almost matches diesel, okay? So this is why it's a really exciting molecule. You've got to consider that with diesel you have SOx and NOx, so the output that you get from hydrogen is ideal for energy transition. And that's when we store it at higher pressures, okay? So that's why you see in mobility, vehicles holding molecules at around 700 bar, between 700 and 350 bar. But one of the other things is it's incredibly versatile, okay? So as an energy carrier, it's really exciting. And you'll have heard lots of different businesses saying, well, let's just convert the hydrogen, we'll just store it locally, and then flip it when we need the energy. A little bit more complicated than that, but essentially that's what we're going to be looking at in the future. So demanding that the grid potential and the generation of power utilising hydrogen is a really exciting step forward. So today you want to hear about H2 Insight. So we've delivered over 200 EPCs now worldwide, everything from pre-feed, feed, right through to installation. But in hydrogen, we've done some really exciting projects. We're currently the first EPC that's helping decarbonize a brewery. So this is Budweiser Brewery, owned by AB and InBev, and they'll look at transitioning their site into utilising hydrogen to generate the alcohol that you all drink, the Budweiser, but also as off-takers using mobility. The two key focuses for us are in green hydrogen and in blue hydrogen. Green hydrogen's fantastic. At the end of the day, that's the end goal. That's where we want to be. That's the gold medal at the end of the marathon. However, we've got to take a few steps to get there. Green hydrogen naturally can be quite expensive and very capex intense. But then we have blue hydrogen. So blue hydrogen essentially links experience with grey hydrogen, but connecting the CCUS portion to the generation of the molecule. So the benefit with this is we can combine current infrastructure that's already out there, that's the pipeline that we already utilize, but can be very OpEx intense. So then how do we link the two? Well, we believe that blue will be the bridge to green hydrogen. So if anybody's in business development here, take a picture of this because this is the one that you want. We believe that we will see hydrogen currently transitioning to less than $1 a kilo, and that's in green hydrogen, but that is with the sort of interaction of blue hydrogen too. So blue hydrogen currently is manufactured between $1 and $2 per kilogram. That's where we're at on mass manufacture of blue hydrogen. But then if you can see, the price will consistently stay at between $1 and $2 a kilo. So that transition is driven by the utilization of modular electrolyzers, increasing those efficiencies, a better developed supply chain, but also stable demand. At the minute, demand is all over the place. So traditional manufacture of H2 from blue, using blue hydrogen, SMR, carbon capture and storage, and then moving into green hydrogen. So lots of other markets we expect, just with lots of other markets, we'd expect that price to come down quite significantly. But the only way we do that is naturally by supply and demand. A lot of the steps that you've seen on the screen there are really critical to allow us to get that price down, but also to bridge the gap between blue and green. So key considerations we've learnt from a lot of our facilities that we have out there, and also the pre-feed and feed experience. So if anybody's not aware of what a pre-feed is, that's essentially before the front-end engineering design. You have an idea, how do I make that idea a reality, but with a little bit of formality involved. A feed essentially gets you to a very sort of localized price, so where the system's going, getting a good confidence in where that pricing is, but also giving you a plus or minus on that. So you get a good feel of where it's at. But also, testing the realism of projects is critical. I can't underestimate how critical it is that you need good pre-feed and good feed to make projects bankable. We see projects all the time failing at final investment decisions, all the time. And that's usually because systems and sites haven't gone through a really robust pre-feed and feed. So I'm going to quickly fly through 4 of these major points that we've learnt, where demand is critical, site choice has a challenge, supply chain, understanding modularity, but also being realistic with what it is that you're asking for. So we talk about high utilization, okay? This system needs to be running 24 hours a day. You need off-takers all the time. If you have not got off-take for that system and it has to stop, you're suddenly losing money. That price is going sky high. So high demand drives high production. So don't restrict yourself to one off-taker. Look at multiple off-takers. So we're seeing some successful projects that have gone through FID that have primary, secondary, and tertiary off-takers lined up. So if the primary off-taker fails, the tertiary and the secondary off-taker comes straight in and takes the molecule. We then also have to think about site choice. So site choice is really critical. Don't go for the cheapest site. Don't go for the site that's got planning permission but is next to a school. You've got to really think about very carefully about where you're positioning these facilities. One of the things that we've learnt is making sure you're not building facilities on a hill, for example, is a good idea. Because if you're putting systems on a hill, you've got to shift all that material to make it nice and flat. Suddenly you have a 6-month incumbent on time of manufacturing your site. Again, off-taker demand, so utilizing industrial clusters. So where there's a large demand of the molecule is absolutely perfect. Next to freight terminals, next to mobility terminals, anywhere where there's a demand for the product. Also, the local region where you're choosing to build your facility is really important because you need to think about what renewable assets are currently available and what assets you might have to put in to make it a success. So you'll see lots of the countries on the map with the green, with very, very high levels of available renewable sources, but also dark blue where there's lots of low carbon resources. So these maps are really important because they allow you to start to map your strategic direction in generation of the molecule. Supply chain engagement, and I'm going to stay on this for a little bit longer because there's lots of supply chain in this room. I used to be in supply chain. I appreciate that large projects and large EPC companies come along and say, we've got these fantastic projects, but none of them seem to come to fruition, right? And that happens a lot. And one of the things that I want to say to you today is thank you. You know, without you, without the supply chain, without the support, we wouldn't be in the position to be able to stand here and say, we've got all these fantastic projects moving forward. But I think one of the biggest things that we've learned from supply chain is, again, being realistic. And I move on to this slide as I start to wrap up in a moment. But what we need to utilize is systems that are modular. So instead of using one electrolyzer, breaking that electrolyzer down to 4, okay? So then you've got supply and demand. You've got peak load and low load. You've got simultaneous loading at the same time. You've also got less risk in failure of one system. And we're starting to see the 4 times 25% effects, essentially 25% redundancy in electrolysis, really important. So we're seeing sites now where we're getting 4 very small electrolyzers that essentially give you your 10 megawatt, your 20 megawatt, or your 50 megawatt site. One of the challenges is, as well, if you go back 5 or maybe 7 years, hydrogen was this fantastic, exciting molecule, and lots of people made such a big investment, right? All your boards were, right, we're on board, we want to make investments, but then very quickly, nothing happens. So the bargaining power of supply chain has gone. You know, you're in a position now where we need to be actually thinking, how do we work with supply chain to sort of massage that approach back into industry, and how do we help sort of encourage you guys to continue to make those investments whilst projects are going through FID. We then also look at the be realistic approach, and this is so critical. The amount of projects you will hear that fail FID is purely because they are not being realistic. You know, realistic prices of what the hydrogen is going to be delivered at, realistic prices of what the site's going to cost, realistic prices of what the electricity is going to cost to power the electrolyzer. Be realistic, and don't be nervous about that. I was sat a few weeks ago working with one of the directors in a very large French bank, and I was asking his advice on how do we create a really compelling pre-feed and feed. And he just said, don't lie to me. And that almost sounds slightly ironic coming from a bank, but it's really interesting because he said every single time projects now have contingencies that are high risk like this of between 100 and 120% of the original input costs, okay? So just bear that in mind. Be realistic and don't be nervous about saying, actually, you can't achieve €1 a kilo of hydrogen, but we can achieve 5, and in 10 years' time, we expect that to be 10 cents a kilo, for example. Be realistic with your approach. And just some positive news on hydrogen. We all saw last week the European Commission release their news around the hydrogen bank and the pilot auction. This, for me, was really enlightening, okay? We're hitting strike prices, or the aim is to hit strike prices of sub €0.5, which is incredibly exciting. I want to see it happen, but let's see it happen. But one of the biggest things for me is this slide here. So if you look at any project that's relatively high risk, relatively challenging, you tell me the expected entry into operation is less than 3 years. I wouldn't believe you, okay? The Hydrogen Commission has had over 130 bids, and the average now is sub 3 years for entry into operation. So this is a really exciting time for us in seeing the market mature. People are being realistic. Historically, people weren't realistic and didn't succeed, okay? So we're now in this position where the market's starting to settle. They're just growing pains into where we need to go. Just a little bit on 4 of our major projects that we've dealt with in hydrogen. So I'm going to touch on the first one, which is over in Australia. This is essentially transferring 25 tons a day of, getting 25 tons a day from hydrogen using raw water. And this is a 1796 to 100 megawatt wind site that's also linking with that. We have the link of green methanol. We have not even touched on the green methanol, but that's really exciting for us because methanol is going to be a great off-taker for hydrogen. Breweries, so energy-intensive breweries are really important. So whiskey distilleries, anything that traditionally could transition to electrification, but now could utilize hydrogen as an off-taker, is a really exciting area of the market for us. And then also owner engineers in Chile. So this is working on projects where there's that front-end engineering design that needs the support and direction to see how it can go forward. I'm going to be at stand D80, which is just over there. I'm going to hang around networking in just a moment, and I'd welcome any questions. But thank you for listening and appreciate your time.